Alrighty, so now we're going to be looking at a few examples for graphing inequalities. So looking at number one, this is our application problem that we've been working with, and it says the Capital City High School wrestling team is doing a car wash. Tickets for a truck are $8 and tickets for a car are $5. The team wants to take in at least $240 at the car wash. Write a linear inequality to determine the number of truck and car tickets that need to be sold. First, we're going to define our variables. So we're going to let x equal, I'm just going to say truck tickets. And we're going to let y equal the number of car tickets. Now, you could have definitely switched that up, but just so we're all on the same page going through the example, this is what we need to go with. Now, we're going to first start by writing a linear inequality to determine the number of truck and car tickets that need to be sold. So we know that tickets for a truck are $8. So that means that 8 has to go with our x right here, because that's our truck tickets. Okay, so we're going to have 8x. We're also selling car tickets, and we know that tickets for a car are 5, so that has to go with our y, so 5y. Now, we want to take in at least $240. If we want to take in at least that amount, that means we can actually gain more than that amount, and that'll be great. Okay, so greater than or equal to, okay, because at least greater than or equal to 240. So that's my inequality that I'm going to have to work with. Okay, this right here is in standard form, so that means to solve this, I'm going to be plugging in my zeros, okay, which we're getting pretty good at. So looking at this, okay, we first have to find our intercepts. So to find the y-intercept, I'm going to have 8 times 0 plus 5y is greater than or equal to 240. This goes away because anything times 0 is just 0. We're going to divide out the 5. And I'll have 240 divided by 5. It's going to give me y is greater than 48. So my y-intercept is going to be 0, 48. Now I also need to find my x-intercept. So now I have 8x plus 5 times 0 is greater than or equal to 240. Well, anything times 0 is just 0, so that goes away. And then 240 divided by the 8 is going to give me x is greater than or equal to 30. So my x-intercept is going to be 30, 0. Alrighty. So now I need to go ahead and set up my graph over here. The reason we have to find the intercepts first is because we need to know how far our scale needs to go. Okay, so my x, we already said the x was going to be truck tickets. So the number of truck tickets. And we need that to go to 30. So I'm going to go up by 2's. And I met my goal. I'm going to keep going a little bit further though. And then my y-intercept was 48. Well, I went up by 2's on the x and I only made it to 40. So for this one, I'm going to go up by 5's. So starting at 0 again, I'm going to go up by 5's. Alrighty. Now, we do have to finish our labels because I got ahead of myself and forgot my labels. So this is going to be the number of car tickets. And here, we're not actually looking at cause and effect. We're looking at a total. Okay, so here we're going to talk about the total car wash sales. Okay, we're not actually looking at an independent and dependent variable. We're looking at a total. So that's why your title is going to be a little bit different for this one. All right, so now we need to plot both of our intercepts. Okay, so our y-intercept was 0, 48. We're going to estimate that's about right here. And our x-intercept was 30, 0. That's way down here. And then we have to connect both of the points. Guys, I'm really impressed with how straight my line was just now. But anyway, so looking at that, we now have our line graphed. Okay, all we need next is our shading, because remember, this is an inequality. Okay, so we wanted everything that was going to be greater than 240. Okay, if I want something that's greater than 240, I'm going to be shading above the line. Okay, I want everything above. So your shading needs to be everything above 240 or above the line, because we want to make greater than the line that we graphed. All right, so there's my lovely shading. I'm sure yours looks beautiful. So now we need to look at our last few questions. The first one asks us to identify the combination of truck and car tickets that, shoot, don't know why it says soccer team. I changed that to the wrestling team. My bad, guys. Okay, could sell to meet their goal. So our first one was 20, 40. So 20 trucks and 40 cars. So we go to plot that point, 20 trucks up to 40 cars. That is in our shaded area. So yes, that is a solution. The next one was 10 trucks and 50 cars. 10 up to 50. Sweet, that's also in our shaded area. We have 30 trucks and 20 cars. Well, that's obviously in our shaded area. That's like over here. And then 40 trucks and 20 cars. Well, that's way over here as well. Okay, so all of these are solutions. Okay, because they're all in our shaded area. Number 2, it says determine if the following points are solutions to y is less than negative 2x minus 1. This is where we need to label our points as x and y, and then substitute those into our function. So we're going to substitute those in. So instead of y, I'll now have 3 is less than negative 2 times a negative 1 plus 3, not plus 3, minus 1. Wowza. Okay, because I just plugged in all of those pieces. And now I'm just going to simplify to see if it gives me a solution. So I'll have 3 is less than negative 2 times negative 1 gives me 2 minus 1. I'm going to keep simplifying, and I'll get 3 is less than 2 minus 1 gives me 1. Well, is 3 less than 1? No, that is false. So this is not a solution. All right, so now we need to do the same thing with the next one. This is still my x and my y. I'm going to plug everything in. So instead of a y, I'll have a 0 is less than negative 2 times, instead of x, I have negative 8 minus 1. Now I'm just going to simplify. So 0 is less than negative 2 times negative 8 gives me 16 minus 1. I'm still just simplifying over here. So 0 is less than 16 minus 1 gives me 15. Well, I have to think, is 0 less than 15? It sure is. That's true. So it is a solution. Woohoo! All right, if you feel like I'm going a little fast, which I kind of am, if I'm going to be honest, please make sure you're hitting pause, asking questions, and getting help. If not, you're right here with me. Go to the next page. All right, so the next one we've got is x minus y is greater than or equal to 2. So for this problem, okay, this is in our standard form. So we're going to go ahead and find our intercepts. So if I'm looking for my y-intercept, I'm going to start plotting or plugging in a 0 for my x. So I'll have 0 minus y is greater than or equal to 2. Well, the 0 just goes away. I still have that negative 1 in front of the y. So I'm going to divide out the negative 1, and I'll get y is, we flip the inequality, so less than or equal to negative 2. So my y-intercept is going to be 0, negative 2. Now we also need our x-intercept. Change my color. Okay, so I'll plug in a 0 for my y. So I'll have x minus 0. It's greater than or equal to 2. Well, the 0 just goes away. solve x is greater than or equal to 2. So my x-intercept is going to be positive 2, 0. Isn't that nice? Now, we know that this is going to be a solid line. Okay. So I'm going to plot my two intercepts. So I've got 0, negative 2, and 2, 0. And then I'm going to connect my points. This line isn't going to be near straight. I can already tell. Okay, notice it goes all the way to the edges. Okay, it's nice and straight. You do have your note cards, so please make sure you're using those. Okay, and now we are going to shade. So we plug in our 0. Remember, to see where we need a shade, we're going to plug in our 0. So my point was 0, 0. Plug that in, and I'll have 0 minus 0 is greater than or equal to 2. Well, 0 minus 0 is just 0 is greater than or equal to 2, which is false. I get a big F for false. So I know my point down here is going to be false because it's wrong. So that means this side has to be true, and that means I shade my true side. So then my next question asks, is the point 0, 2 a solution? Well, the point 0, 2 is up here in the non-shaded area. Since it is in the non-shaded area, it is not a solution. Okay, because it's not in the shaded area. Remember, it has to be in the shaded area or on a solid line for it to count. All right, last one. Okay, I've got the point or the equation. Y is greater than 5. That right there is going to be dashed. And this is my HOI. So I know it's going to be a horizontal line going through 5 on the y-axis. So it's going to be this dashed line right here. Now, I still want to check 0, 0. Okay, so I'm going to plug in a 0 for my y, and I'll have 0 is greater than 5. Well, is that true? This is nope. Okay, that's a big false. Okay, so since 0 is false, that means I'm going to shade everything above the line, which makes sense because I want all the y's that are greater than 5. Greater than would be above. Then my last question asks, is the point 1, 5 a solution? Well, if I plot the point 1, 5, that is right on my dashed line. So since it is on a dashed line, it is not a solution. No, because it's on a dashed line. Alrighty, if you guys have any questions about this stuff, please let me know. If not, you can move on to your homework.